Welcome everyone to Beluga Space Tours. I want to thank everyone aboard for joining me on our tour departing from Sol to Trappist-1. Our destination is Trappist-1e, and on the way we'll be passing Trappist-1b, C, and D. Trappist-1 has fascinated humanity for thousands of years. Sitting relatively close to Earth at 41 light years, Trappist-1 was an excellent target for early observations. Trappist-1 was cataloged 1,308 years ago in 1999 using the 2-micron all-sky survey, also known as 2MASS. 2MASS was a survey of the sky in infrared. During its operation, it cataloged over 300 million objects. At the time of Trappist-1's discovery, it was called 2MASS J23928-0502285. Really rolls off the tongue, doesn't it? Wonder why it didn't stick. In 2016, a group of scientists observed the system further at the Transiting Planets and Planetesimal Small Telescope, or TRAPPIST, located in Chile. Using the transit method, they discovered 3 potential Earth-sized planets orbiting Trappist-1. On your screens, you can now see Trappist-1b as it passes across Trappist-1. Because the orbit of Trappist-1's planets align with Earth's, early astronomers could detect these exoplanets as they passed their star. The transit method was an invaluable yet rare opportunity for us to observe exoplanets when we were bound to Earth. As astronomers observed stars from Earth, precise measurements of their luminosity were recorded. As an exoplanet passes between the star and Earth, it will create a small dip in luminosity, indicating an exoplanet's existence. Not only can the transit method detect exoplanets, but it can also measure the orbital period and mass of the planets. The data indicated the 3 planets had rocky compositions, prompting a more in-depth study. NASA's Hubble telescope then studied the atmospheres of Trappist-1b and C. The light passing through the transiting planet's atmosphere showed little signs of hydrogen, characteristic of a gaseous world. Then, in 2017, the Spitzer telescope studied the system for 21 days, confirming the first 2 exoplanets, as well as finding the 3rd planet was in fact 3 planets. 2 additional exoplanets were then discovered, totaling 7 planets orbiting Trappist-1. Trappist-1 is an ultra-cool dwarf star with a temperature of 2500 Kelvin. The system is very compact, with the furthest planet Trappist-1H orbiting Trappist-1 every 19 days. 3 planets sit in the habitable zone, Trappist-1d, E, and F. Our destination, Trappist-1e, was believed to be the most likely candidate to support life. Being tidally locked, the planet's space-facing side would be too cold to support life, while the planet's sun-facing side would be too hot. The transition between these 2 extremes was thought to potentially support life. On the terminator line of Trappist-1e, the temperature is an average of 246 Kelvin, which will allow liquid water to form and support life comfortably. Before the invention of the frameshift drive, when space travel was mostly limited within Sol, a foolish group of people attempted to fly to Trappist-1. Let's just say their ship is likely still on its way. Even flying as we are now in supercruise, where we can travel faster than the speed of light, it would take years for the trip. Unfortunately, due to strict federal restrictions, landing on Trappist-1b is not permitted. Even if we had the clearance to land, our ship wouldn't be equipped to handle the harsh winds of the planet. You may have noticed moons orbiting Trappist-1e. It wasn't until 2200 until scientists discovered moons in the TRAPPIST system. It just goes to show that our understanding of the universe is constantly changing as we discover more and more things. This concludes our tour of Trappist-1e. Again, thank you for choosing Beluga Space Tours, and enjoy the view.